This is class 26 of my arithmetic course. Today we're going to learn proportions. If you haven't done the homework from the last class completely and correctly, do that homework before watching this video. First, let's talk about what a proportion is. A proportion is an equation that says that two fractions are equal. If you reduce 4/8 to 1/2, you can see that the equation is true. Therefore, the proportion is true. Of course, you can also change 1/2 to 4/8, and that will demonstrate that the equation is true also. Now, the big question is, why do we care about proportions? Well, the reason that we care about proportions is that they help us solve real-world problems. For example, if you're making biscuits, and the biscuits require 2 cups of butter for every 7 cups of flour, and you have 4 cups of butter, and you want to use all that butter up, how many cups of flour do you need to use all 4 cups of butter? That's a proportion problem. So let's start with determining if a proportion is true. So number 1, notice the question mark. We want to figure out if these two fractions are equal. We want to figure out if they're proportional. So in order to do this, all we have to do is just reduce this fraction to lowest terms, and if after we reduce it to lowest terms it equals this fraction, then the proportion is true, because this fraction is already in lowest terms. So rewrite the fraction that's in lowest terms. And if we divide both sides of the other fraction by 4, 12 divided by 4 is 3, and 20 divided by 4 is 5. So you can see the fractions are equal, and the proportion is true. Now let's try number 2. If you divide both sides of this fraction by 2, then you get 5 over 11 is equal to 1/2, and that's not true, because both fractions are in lowest terms, but they're obviously not the same fraction. So we say that the proportion statement is false. And we have to write not equal to. So in this equal sign, we write a slash, meaning 5/11 is not equal to 1/2. So why don't you try number 3, and when you come back, we'll do it together. All right, we're back. If you reduce 4/6 to 2/3, you can see that this proportion statement is true. So if you said the proportion is true, good job. But remember, you have to show your work here. You have to show that intermediate step. Why don't you try number 4, and when you come back, we'll do it together. All right, we're back. So as you can see, 3/5 is already in lowest terms. So all we have to do is reduce 8 over 18. If we divide both numbers by 2, 8 divided by 2 is 4, and 18 divided by 2 is 9. So you can see that these fractions in lowest terms are not equal to each other, so we put a slash through them and we say the proportion is false. All right, let's try number 5. With number 5, there's a difference here. These problems are different because in this case we have to reduce both fractions. In the previous problem, we only had to reduce one fraction. So let's reduce 10 over 12. That becomes 5 over 6 if we divide both sides by 2. And if we divide both sides of the other fraction by 5, we get 8 over 9. And you can see that those fractions are not equal, so we put a slash through the equal sign, and we say the proportion is false. So again, in these problems, you had to reduce both the fractions. Let's try another one. If we divide both sides of this fraction by 5, then we get 4 over 7. And if we divide both sides of this fraction to reduce it to lowest terms, we divide both sides of that fraction by 2, we get 4 over 7. So you can see that the proportion is true. So why don't you try number 7, and when you come back, we'll do it together. All right, we're back. Reduce 12 over 16 to 3 over 4, and 9/12 reduces to 3 over 4, so the proportion is true. So if you said the proportion is true, good job. Why don't you try number 8, and when you're done, we'll come back and do it together. All right, we're back. Divide both sides of this fraction by 9, and you get 8 over 9. And divide both sides of the other fraction by 3, and you get 7 over 9. So you can see that the proportion is not true, so we put a slash. Don't forget to put that slash through the equal sign, and the proportion is false. So if you said false, good job. But remember, you got to show the work here. This is the work that we're showing as the intermediate steps. All right, so number 9, it's the same exact problem, same type of problem. The only difference is now we're showing units. Proportions set fractions equal to each other, but sometimes these fractions can be rates. In this case, this is a rate. It's miles per hour. It's a rate because the units are different in the numerator and the denominator. But if the units are the same, then we would call these ratios. We'd be setting ratios equal to each other. But this is really the same type of problem. So if you reduce 8 over 24, that becomes divide both these numbers by 8, and we get 1 mile for every 3 hours. And the fraction on the right is already in lowest terms. So we can't do anything to that. And you can see that 1/3 is not equal to 7 over 23. So we have to write not equal to, and the proportion statement is false. Why don't you try number 10, and when you come back, we'll do it together. All right, we're back. The fraction on the left side is already in lowest terms, so we can't do anything with that. But the fraction on the right, we can divide both numbers by 4 to get $1 for every 2 pounds. And you can see that this equation is not true. 8/15 is not equal to 1/2, so the proportion statement is false. So if you said false, good job. But remember, you have to show this intermediate work. Don't skip over that work. All right, number 11, 16 feet for every 8 jumps is equivalent to 20 feet for every 10 jumps. So in that case, what we have to do is we just set up a proportion. 16 over 8 is equal to 20 over 10, and we put a question mark because we don't know if that's true. We're going to try to prove that that's either true or false. So divide both sides of the fraction on the left by 8, and you get 2 over 1. Divide both sides of the fraction on the right by 10, and you get 2 over 1. And you can see that the proportion is true. So there you go. You can write proportions with sentences also. All right, so let's go on to number 12. For number 12, well, why don't you try that one yourself? Actually, let's do this one together. Divide both sides of the fraction on the left by 6, and you get 5 over 1. and 14 over 3, we can't do anything to that. So you can see that this proportion is false. So the only difference with this problem is that we actually had a whole number over here. 5 over 1, that's the same thing as just saying 5. So we could actually get rid of that 1 and just say 5 is not equal to 14 over 3. Or you can keep the 1. So why don't you try number 13, and when you come back, we'll do it together. All right, we're back. We can divide both sides of the fraction on the left by 3, and then you get 3 over 1. Divide both sides of the fraction on the right by 5, and you get 4 over 1. And that's the same thing as saying 3 is equal to 4. Because remember, 3 over 1 is the same thing as 3, and 4 over 1 is the same thing as 4. So obviously 3 is not equal to 4, so we have to put slashes, and we say that the proportion is false. So if you said false, good job. All right, so now we're going to number 14. Let me shrink this stuff here, get it out of the way. Now we're going to solve proportions. So these are problems that represent the biscuit example that I gave at the beginning. In the previous problems, all we were doing was just trying to figure out if the proportion is true. But in these problems, we're assuming that the proportion is true. We're assuming that it's true. We're not trying to prove that it is true. We're assuming that it is true, and we're trying to find a missing number in the proportion. So here's how we do this. Again, we're looking for this missing number. We don't know what n is. We're trying to figure out what it is, and we're assuming that the equation is true. The proportion is true. So here's what we do in these particular problems. There's actually 3 different ways to solve these problems. Actually, there's probably more than 3, but there are 3 variations of these problems that I'm going to show you. So here's what you do in this first variation. You reduce this fraction. So if you reduce that fraction, divide both sides of the fraction by 3, and you get 8 over 9. And just rewrite the other fraction. So now we have 8 over n is equal to 8 over 9. Now, if we assume that these fractions are equal and the numerators are the same number, whoops, getting rid of that highlight. If we assume the numerators are the same number, in order for the fractions to be equal, n would have to be the same number as the denominator because the numerators are the same. Again, if we assume the fractions are equal, the denominator has to be 9. Let's try number 15. Again, we're going to reduce. We're going to reduce this fraction. Divide both sides by 3, and you get 1 over 5 is equal to a over 5. So again, because we're assuming that the equation is true and the denominators are the same, that means the numerators have to be the same in order for the fractions to be equal. So that means a has to be 1. Again, that's just simple logic there. A must be 1. So why don't you try number 16, and when you come back, we'll do it together. All right, we're back. Divide both sides of the fraction on the left by 7, and you get 6 over 9 is equal to 6 over b. And because the numerators are the same, you get 6 and 6, the numerators are the same, that means that the denominators have to be the same too. So b is equal to 9. So if you got 9 for b, good job. Why don't you try number 17, and when you come back, we'll do it together. All right, so we're back. Let's reduce 12 over 18. If we reduce that, it becomes 2 over 3. And because the denominators are the same, that means the numerators must be the same, so n must be 2. So if you got 2 for n, good job. All right, so now we're going to do word problems that use proportions. So this is like the biscuit problem that we did. If a bird flies 22 miles, let me focus in on this. Whoops, sorry. It jumps around like that. I don't know why. If a bird flies 22 miles in 55 minutes, how long would it take this bird to fly 2 miles? Write a proportion statement and use it to solve this problem. So when they say proportion statement, they just mean write an equation. So let me show you how to do this. So we know the bird travels 22 miles. Let's make that smaller. 22 miles in 55 minutes. And it says, how long will it take the bird to fly 2 miles? So we're going to write T for time because we're trying to figure out how long. So that's the proportion statement. So again, this is just like the biscuit problem. So we know the bird flies 22 miles in 55 minutes. So how long will it fly in 2 minutes? Now here's the important thing to understand. When you set up a proportion like this, if you put miles at the top, if you put miles at the top in this fraction, then miles have to be at the top in this fraction also. And that would mean that minutes are going to be in the bottom in both fractions. If you switch it around so that minutes are in the bottom here and minutes are in the top, then you're going to get the wrong answer. All right, so let's reduce the fraction on the left. If we divide both sides of the fraction on the left by 11, then we get 2 over 5 is equal to 2 over t. And you can see that t must be 5. So we solved the proportion in the same way that we did with the previous problems. But this is a word problem, so before I rectangle, I have to say 5 minutes. If I didn't say minutes, I would get points taken off on a test. All right, so if you have a word problem, you just set up a proportion statement and then just solve it. So why don't you try number 19, and when you come back, we'll do it together. All right, we're back. 40 calories are burned for every 90 feet that you run. And it says how many calories will be required to fly 9 feet. So the calories are on top and the feet are on bottom. So we need to write the feet, the 9 feet, on the bottom. And the missing variable, which is calories, we'll write as C for calories. So all we have to do is reduce the fraction on the left by dividing both numbers by 10, and you get 4 over 9 is equal to C over 9, which obviously means that C is equal to 4. Now it's very important, if you don't have room down here, that you can just write an arrow. Always write an arrow, because that organizes your work and shows the reader where your answer is going to be. But we have to say calories. And be sure to write more legibly than I'm writing right now. I just ran out of room there, but that's no excuse. All right. So again, those are word problems that require you to use proportions to solve them. Now I just want to mention that in the previous class we learned how to solve these problems with unit rates. We can solve this problem by finding the unit rate first, then using that unit rate with this number to find the time it takes for the bird to fly 2 miles. So we already know how to solve these types of problems using unit rates. But just keep in mind that the unit rate you would have to write either as 2/5, or if you change it to a decimal, it would be 0.8. And that would give you the number of miles that the bird flies in 1 minute. So the bird would fly 0.8 miles in 1 minute. And then you would have to use that number to figure out how long it would take to fly 2 miles. Again, we did that in the previous class. But in this class, we're learning how to solve these problems using proportions. All right, so number 20. Now number 20 is going to be a different problem, because in all the previous problems, in order to solve the proportion, we reduced a fraction. In this problem, we're not going to reduce a fraction. We're actually going to make the numbers bigger instead of smaller. So remember, the fundamental principle of fractions, that's the most important thing to remember when it comes to fractions. You can multiply both the numerator and the denominator by the same number, and the fraction remains the same value, or you can divide both the numerator and the denominator by the same number, and the fraction remains the same value. So we can multiply both sides of the fraction on the left by 2, and we get 18 over 8 is equal to 18 over n. And now, because the numerators are the same, we know that the denominators must be the same, because again, we're assuming that this equation is true. It's not asking us to prove that it's true. It's assuming that it is true. So therefore, n has to be 8. So again, we had 18 here, and we needed this number to be 18. So that's why we multiplied both sides of this fraction by 2, because then we got 18 over 8. And therefore must be 8. So let's try number 21. Why don't you try number 21 on your own? And it's the same type of problem. You're going to have to multiply both sides of the fraction instead of dividing both sides of the fraction. But remember, you have to set up your proportion statement and make sure that the units are the same in both numerators of the fraction and the denominators of the fraction. So try that problem, and when you come back, we'll do it together. All right, we're back. There are 5 ounces of silver for every 2 ounces of gold, and it says how many ounces of gold would be present with 30 ounces of silver. So we'll put 30 there, and we'll put G for gold. So in this problem, we have 30 here, so we want this number to be 30. So in order to make 5 30, we have to multiply both sides of this fraction by 6. And then we get 30 over 12 is equal to 30 over G, and then we can easily see what G is. G must be 12. But this is a word problem, so we have to say 12 ounces. OZ is the abbreviation for ounces. So if you got 12, good job. You can also spell out the word ounces, obviously. All right, so 5 over 2. Let me just check the work on that. It looks good. So let's try number 22. 22 is the same situation. Attempt that problem, and when you come back, we'll do it together. All right, we're back. We have 14 here, so we want this number to be 14. So we multiply both sides of the fraction on the right by 2, and we get 16 over 14 equals b over 14, therefore b must be 16. If you got 16, good job. All right, why don't you try number 23, and when you come back, we'll do it together. All right, we're back. There are 2 gallons of red paint for every 7 gallons of white paint. If you have 21 gallons of white paint, how many gallons of red paint would you use? So I'm going to put uppercase G for gallons. Actually, I'll just put R for red paint. So in this case, we want to make this number 21 so that it equals the denominator. So we're going to multiply both sides of the fraction on the left by 3. So we get 6 over 21 equals R over 21. So because the denominators are the same, obviously that means the numerators have to be the same. So we would have 6 gallons of red paint. And be sure to write 6 gallons of red paint. So if you got 6 gallons, good job. All right, let's do one last problem like this. And why don't you try 24, and when you come back, we'll do it together. All right, we're back. So we want this number to be 100 because the numerator in the other fraction is 100. So we're going to multiply both sides of the fraction to the right by 10, and we get 100 over 90. So obviously n equals 90. So if you got 90, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, so we're on to number 25. Now, in number 25, if you notice, we can't really do anything to make the numerator to make the denominators equal. We want to multiply 8 by something to get to 5, but that's not very easy. And we could multiply, we could reduce this fraction, but obviously it's already in lowest terms, so that's not going to work either. So again, in the first problems that we did, we reduced the fraction to make the denominator 5, but that doesn't work because this is already in lowest terms. And in the next type of problems that we did, we multiplied. We went the opposite direction. Instead of dividing to reduce the fraction, we multiplied both sides of this fraction to make the numbers bigger to get 5 in the denominator. But that won't work because 8 is already bigger than 5. So if we multiply 8 by something, it's just going to make it bigger. So those methods are not going to work. So what that means is that this proportion is just a more difficult proportion to solve. And what this simply means is that n is actually going to end up being some sort of a decimal or fraction. So in order to solve this proportion, we have to come up with a more sophisticated method to solve it. It's a more powerful method. So here's the method. It's very simple. What we're going to use is something called cross multiplication. We're going to multiply, let me make that a little less thick there. We're going to multiply n and 8, and we're going to multiply 5 and 7. So 5 times 7 is 35, and n times 8 is just n times 8. So again, there's a principle in math that says that if a proportion is true, that means the cross products must be true. Instead of writing 35, I'm going to just write 5 times 7 for here. So these are called cross products. If the proportion is true, then the cross products must be equal. That's a principle that you're going to learn in math. So 35, 5 times 7 is 35. So now, again, our answer is going to be a fraction, so you know this is not going to be super simple, but we're going to try to get this done as quickly as possible. So 8 times n is equal to 35. So that means you're going to, remember, multiplication is just another form of addition. So you're going to add up 8 a bunch of times until you get to 35. You just want to know how many times you add up 8. So this problem is simply saying how many times does 8 go into 35. So that's a division problem. 35 divided by 8. You know what, I should probably do this off to the side. 35 divided by 8. How many times does 8 go into 3? 8 doesn't go into 3. 8 does go into 35. Let's see, 8 times 4 is 32. Subtract 35 minus 32 is 3. We have a remainder, so we have to keep going, bring down the 0. 8 goes into 30 3 times. 8 times 3 is 24. 30 minus 24 is 6. We have to keep going, so write a 0, bring it down. 8 goes into 60 7 times. 8 times 7 is 56. 60 minus 56 is 4. And again, if you're rusty on long division, then you can go back to the class where we learned long division. long division of decimals. So bring down another 0, and now 8 goes into 40 exactly 5 times. So put your 5 up there, and then 8 times 5 is 40, and so finally you can see that we have a remainder of 0. 40 minus 40 is 0. So then there's the decimal on the 8 is right here, and it's already up against the line, so we don't have to move this decimal over, we just bring it straight up. So n is equal to 4.375. So if you were wondering why it was difficult to find n, you can see why. N is a number that includes a fraction, 4.375. So again, when you have a decimal or some sort of fraction as your solution to the proportion, then you're going to have to use a more powerful form of the calculation to figure out the answer. And it's called the cross product method. So let's try another one of those. So again, we can see in number 26 that this proportion is not easy to solve, so we're going to multiply 5 times 6 and set it equal to the product of 4 and a. And 5 times 6 is 30. So now we're trying to figure out how many times we add 4 to get to 30. How many times does 4 go into 30? So we'll do that off to the side here. 4 goes into 30. Actually, you know what? I'm gonna do this work over here in the margins. That's perfectly fine to do your work in the margins. 4 doesn't go into 3, but it does go into 30. It goes in 7 times. Bring down a 0, put your decimal. 4 goes into 25 times. 4 times 5 is 20. 20 minus 20 is 0. Bring the decimal straight up, and we got 7.5. So A is equal to 7.5. All right, so again, this is a more sophisticated method, a more powerful method to find the solution of a proportion. So you're going to use cross products on number 27. Why don't you try number 27, and when you're done, we'll come back and do it together. All right, we're back. So 7 times 3 and 2 times b. 7 times 3 is equal to 2 times b. 7 times 3 is 21. So now we're just trying to figure out how many times 2 goes into 21. So we can do that over here. 21 divided by 2. Now in this case, 2 definitely goes into 2. So in that case, we're going to put the 1 above the 2. That's different from the previous problems that we did. See, if 2 didn't go into 2, but it did go into 21, we'd put our number above the last digit of the number that we're dividing into, which would be 1, so our number would go here. But in this case, 2 actually does go into 2, so we have to put the number above 2. You always put the number above the last digit of the number you're dividing into. 2 times 1 is 2. 2 minus 2 is 0. But we still have more numbers here, so we have to bring down the 1. After we bring down the 1, 2 doesn't go into the 1. So we have to put a 0 up here. And we still have a remainder, so we have to put a decimal and bring down a 0. And now 2 goes into 10 5 times. And 2 times 5 is exactly 10. 10 minus 10 is 0, so we have no remainder. Now we just have to figure out where the decimal goes. Now in the divisor, the decimal is already here. It's already right up against the line, even though we can't see the decimal. It's invisible because it's a whole number. So we just bring that decimal straight up, and we have 10.5. So B is equal to 10.5. And by the way, it doesn't matter if you put the 2 times B on the left side or the right side. you can switch these equations. There's a rule called the symmetric property of equality where you can just flip this equation. It doesn't matter which side is which. All right, so if you got 10.5, good job. If you didn't, that's okay. Let's try another problem. So try number 28, and when you come back, we'll do it together. All right, we're back. 2 times 9 is equal to c times 5. Two times 9 is 18. So now we just have to figure out how many times 5 goes into 18, because we know 5 times some number. If you add up 5 a certain number of times, you get 18. We just don't know how many times we add 5 up. How many times does 5 add up to go into 18? So how many times does 5 go into 18? That's a division problem. 5 doesn't go into 1, but it does go into 18 3 times, and notice the 3 is above the last digit of the number that I divided into. 3 times 5 is 15. 18 minus 15 is 3. So we have a remainder. We have to keep going, bring down a 0. Let me move this stuff over. And 5 goes into 30 exactly 6 times. 5 times 6 is 30. 30 minus 30 is 0. So that means that C, I got to put my decimal, so bring the decimal straight up because the divisor is a whole number, so we don't have to move the decimal over. So C is equal to 3.6. So if you got 3.6, good job. Again, we're using a more powerful method to solve these proportions. All right, so now we're going on to word problems. This is the same. You solve these problems the same way we did the other problems, except you have to use cross multiplication. If a submarine travels 6 miles in 11 hours, how much time would be necessary for the submarine to travel 3 miles? Write a proportion statement, which I just did, and use it to solve this problem. All right, so now we just solve the proportion statement. Solve the proportion problem. So as you can see, we can't do it the easy ways like we did in the first problems. So we have to use the cross multiplication method. 6 times t is just 6 times t, and 11 times 3, we'll just write 11 times 3, and 11 times 3 is 33. So how many times does 6 add up to get into 33? So that just means 33 divided by 6. 6 goes into 33 5 times. 6 times 5 is 30. 33 minus 30 is 3. So we have to bring down a 0. 6 goes into 35 times. 6 times 5 is 30. 30 minus 30 is 0. Bring the decimal straight up. And again, we would not bring the decimal straight up if this divisor had a decimal that were, for example, over here. If the decimal were over here, we'd have to move it 2 places to get to this line, which means we'd have to move this decimal 2 places and then bring it straight up. So just be aware of that. But because the decimal is already next to this line, because remember, when in a whole number where the decimal is invisible, the decimal is always directly to the right of the number in the ones place, which is right here. So because the decimal is already up against that line, all we have to do is bring the decimal straight up. So I'm sorry if I'm boring you with all that information, but you need to remember that stuff. So t is equal to 5.5. And notice that I flipped the side that the letter appears on. It doesn't matter which side it is. Now this is a word problem, so we have to say 5.5 hours. If you don't say hours, you'll get points taken off on a test. So now why don't you try number 30, and when you come back, we'll do it together. All right, we're back. We have to write a proportion statement, 20 pounds of meal for every 9 horses. How much meal would be required for 4 horses? So we'll put, we can either put P for pounds or we can write M for meal. I'm just going to write M. All right, so we have to use cross multiplication. 20 times 4 is equal to 9 times m. 20 times 4 is 80. I just realized that this problem might be a repeating decimal. So I'm sorry I gave you a repeating decimal without doing it together first. But technically you should know how to do repeating decimals because we've already done this. This is review. So how many times does 9 go into 80? So let's see if we can move this over a little bit. How many times does 9 go into 80? 9 goes in 8 times. 8 times 9 is 72. Subtract, you get 8. Bring down a 0. 9 goes into 80 8 times again, 72. And you can see it's just going to be a repeating decimal. Bring the decimal straight up and you have 8.888888, which means that m is equal to 8.8 bar. So I'm sorry I gave you a repeating decimal. We have to write the units also. And this is pounds of meal, but we can just say pounds. So again, I'm sorry I gave you a repeating decimal on that problem. All right, number 31. For number 31, we're going to have a really difficult repeating decimal, but I'm going to show you how to write the answer as a, let's see, it's going to end up being just a fraction. We'll just write the answer in this case as a fraction. So we have to use cross multiplication once again. And we get 3 times 2 is equal to 7 times b. 3 times 2 is 6. And now we have to figure out how many times 7 goes into 6. So that's the same thing as saying 6 divided by 7. Let me shrink this. So we're doing 6 divided by 7. But if we use long division, like I said, we're going to have a really, really horrible repeating decimal that's just going to go on and on and on and on. So the division is going to take a long time. So remember in the last class we mentioned briefly that 6 divided by 7, that can just be written as 6 over 7. So we can just write the answer as 6 over 7. Now again, I know we haven't gone over that a lot. We're going to go over that in more detail in the next class. But b can just be written as 6 over 7. Because remember, if you want to change 6 over 7 to a decimal, which is what we were about to do, you would take the numerator. This is changing a fraction to a decimal. We learned that in a previous class. You take the numerator and divide by the denominator. So numerator divided by denominator. But what we're doing is we're going backwards. We want to find 6 divided by 7. So we're just writing that in fraction form, going in the reverse direction. All right, so why don't you try number 32. Number 32, you can either write as a repeating decimal or you can write as a fraction. So try 32, and when you come back, we'll do it together. All right, we're back. So we have to use cross multiplication. 4 times 1 is equal to n times 9. 4 times 1 is just 4. And we have to see how many times 9 goes into 4. That's just division. How many times does 9 go into 4? But remember, 4, that's 4 divided by 9. It's the same thing as 4 divided by 9. So 4 divided by 9 can just be written as 4 over 9, and you're done. Now, if you wrote it as a repeating decimal, then you would have to use long division. So 9 does not go into 4, so we have to add a decimal and a 0. Now 9 does go into 40. It goes in 4 times. 9 times 4 is 36. 40 minus 36 is 4. Bring down a 0. 9 goes into 40 4 times. 9 times 4 is 36. And you can see it's just going to keep going on and on. So it's a repeating decimal. So n can also be equal to, and bring the decimal straight up, put your 0 there so the decimal doesn't look like a speck of dirt, and you have 0.4 bar. That's also an answer that is acceptable. All right, so again, if you're having trouble with these concepts or these algorithms, just go back and review the classes that we did on dividing decimals. So let's try number 33 now. The only difference with 33 is we're going to have a 2-digit number for the divisor. So 7 times 8 is equal to C times 11. 7 times 8 is 56. How many times does 11 go into 56? So now we have a double-digit number. That's the divisor. So how many times does 11 go into 5? It doesn't go into 5, but 11 does go into 56. It goes 5 times. 5 times 11 is 55. 56 minus 55 is 1. So we have a remainder. We have to keep going, and so on and so forth. But remember, well, actually in this case, we'd have an improper fraction. You can write C as 56 over 11. 56 divided by 11 is the same thing as 56 over 11. We explained that in the previous problem up here. 6 divided by 7 is the same thing as 6 over 7. You're just going in the reverse direction. We haven't talked about that a lot, but I want you to start getting used to that. So now we have to break out more tricks that we learned in previous classes. I know you're probably thinking you're already sick of the tricks that we're having to pull out, but we have to change this fraction to a mixed number because this is an improper fraction. The numerator is bigger than the denominator, so it's not traditional to leave it in that form. So 11 goes into 56 5 times, so that's your whole number. And we already know the remainder is 1, so that's the numerator of your fraction, and the denominator just stays the same. So C is equal to 5 and 1/11. Now you could also write it as a decimal by continuing with the long division here. Bring down the 0. 11 does not go into 10 after you bring down the numbers, so you have to put a 0 up here. Then you bring down another 0. 11 goes into 100 9 times. 9 times 11 is 99, and you have a remainder of 1. Then you bring down a 0, and after you bring down the 0, 11 still doesn't go into 10, so you have to put a 0. Then you bring down another 0, and 11 goes in 9 times, and you can see that if we bring the decimal straight up, you just have 0909090909. So another way to write this is 5.09 bar. So again, if this math is causing you to have a lot of anxiety, that's okay. Just go back to the previous classes and review mixed numbers and dividing decimals and converting fractions to decimals and all that type of stuff. All right, so let's try. Whoops, sorry about that. Let's try number 34. And when you come back, we'll do it together. All right, we're back. 61 times 9 equals 36 times n. 61 times 9, that would be, we can do it over here if you want. 9 times 1 is 9, 9 times 6 is 54. So we have 500, let me try to stay in the lines here. 549 equals 36 times n. So we're trying to figure out how many times 36 goes into 549. So we can either write it as a fraction or a decimal. Either way, we'll do it both ways. We'll do a fraction and a decimal. So 36 doesn't go into 5, but it does go into 54. It goes in 1 time. 1 times 36 is 36. 54 minus 36, you can either do that in your head or you can use the borrowing method. We can't subtract 6 from 4, but we can cross out 5, make it a 4, and borrow 1 and give it to the 4. So we have 14 minus 6 is 8, and then 4 minus 3 is 1. Again, that's a 4 because we borrowed 1 from the 5. So now you have 18. So now we have to bring down the 9, and now we have to do 36 and 189. So that's a big number. So let's just try some numbers. Let's try maybe 5 times. 5 times 36. You can set it up like this if you want, but I'm just going to do it in my head because we're pressed for time. 5 times 36 is going to be 180. So it looks like that's going to work. Also, if you put the 5 here, you can use the method that we learned previously. So 5 times 6 is 30. Put your 0, carry the 3 up here. 5 times 3 is 15, plus 3 is 18. That's another way to do the multiplication quickly. But I find a lot of students get angry when I show them that method. All right, so 189 minus 180 is 9. And at that point, we can write the answer as a mixed number. So we know that 36 goes into 549 15 times. And the remainder is 9, and the denominator just stays the same as 36. So that's one way to write the answer. Actually, I just realized 9 over 36 can be reduced. If we divide both sides of that fraction by 9, we get 1 over 4. So a lot of math going on here. So if you want to change it to a again, 549 over 36 is another way to write this. So we just change this improper fraction to a mixed number. But the other way we can do it is we can keep going with this division. Add a 0, bring it down. 36 goes into 90 2 times. 2 times 36 is 72. Subtract and you get 18, and it looks like it's just going to keep, well, actually I don't know what it's going to do. 36 goes into 180. We already figured out that's 5 times exactly, so I guess it's not going to be a repeating decimal. Bring the decimal straight up, and we have 15.25, so that's another way to write it. 15.25, that makes sense because 1/4 is the same thing as 25 1/100ths. So as you can see, the math can get quite difficult, but again, you should know all of this math from the previous classes. But if you are rusty on the math, that's okay. Don't be worried about this. Just know that you're going to have to review this stuff before you take the exam. That's just the way that classes work. As the class goes on and on, as the amount of time that you've been in the class increases, the difficulty of the class also increases. So that's just the way it is in every class. There's no way to avoid that. You're required to learn stuff that you went over in the first parts of the course. All right, so now we're going to go to word problems that use proportions. So we learned ratios in the previous class. Ratios are just relations between two numbers, and you can write a ratio as a fraction. You can consider these to be ratios if you really wanted to. These are just setting ratios equal to each other, or rates. Proportions work for rates and ratios. So let's read the problem. The ratio of Jim's coins to Arnold's coins is 5:3. If Jim has 20 coins, how many coins does Arnold have? So again, we already learned ratios, but this problem requires us to set two ratios equal to each other. So this is actually a problem that involves a proportion. So in the previous class, we learned how to solve this using equivalent ratios. So we know that Jim's the ratio of Jim's coins to Arnold's coins is 5:3, and we want Jim to have 20 coins. And we're looking for how many coins Arnold has. So what you can do is you can find equivalent ratios. You can multiply both those numbers by 2 to get 10 and 6, or you can multiply both these numbers by 3 to get 15 and 9, but we still don't have 20. We want this number to be 20. It's not 20 yet. So now multiply both these numbers by 4, and you get 20 to 12, and that's what we're looking for. So now Jim has 20 coins, and we can see that the answer to the problem is 12, because we know if Jim has 20 coins, Arnold has to have 12 coins. But let's see here. Yeah, let's go ahead and show both methods. So that was a method that we learned previously. But we can also use a proportion equation to solve this problem. So that's one method. But we can also say the fraction 5/3 is equal to 20 over a. Then we multiply both sides of that fraction. We want 20 in the numerator. So we multiply both sides of 5/3 by 4, and we get 20 over 12 is equal to 20 over a. And because the numerators are the same, we can see that a is 12. So you can solve this equation by using equivalent ratios, but you can also solve it by using a proportion statement. But the key thing to understand is that this problem is actually a proportion problem. It's setting up a proportion and asking you to find the missing number. So you can use whatever method you want to use. And we have to say 12 coins. Arnold has 12 coins. All right, let's go to number 36. If the ratio of Rolex watches to Casio watches is 2:7, and there are 28 Casio watches, how many Rolex watches are there? So we can use the method of ratios, or we can use the method of setting up a proportion. The method of equivalent ratios, sorry. So 2:7, right, 2 over 7, and then there are 28. So it says Casio watches, Rolex watches to Casio watches. So the 2 represents the Rolex watches, and the 7 represents the Casio. So we have 28 is the Casio watches. These two numbers have to be in the bottom, both in the bottom or both in the top, but they have to be in the same level because they both represent Casio watches. We'll just write R for Rolex watches. And you can see you just multiply both sides of this fraction by 4 to get 8 over 28 is equal to R over 28, and we can see what the solution is. Because the numerators are the same, the denominators are the same, so the numerators must be the same. So R equals 8 Rolex watches. So we use the method of we set up a proportion statement for that. But you can also use equivalent ratios. For example, you can set up 2:7, multiply both by 4, and you get 8 to 28. And you see there are 28 Casios, so there must be 8 Rolexes. You can use either method. All right, number 37. You can choose to use this method, or you can use this method. It's up to you, but just keep in mind that in the homework, you're going to have to use both methods. I'm going to actually tell you which method to use, and you have to know how to use either method. So you might want to try using both methods eventually. So try number 37, choose which method you want to use, and when you come back, we'll do it together. All right, we're back. The ratio of bluebirds to sparrows is 8:7, so I'm going to use the proportion method. 8 over 7 And we want to know if do we put 48 here or do we put 48 in the numerator. One way is wrong and the other way is correct. So it says it's the ratio of bluebirds to sparrows. So bluebirds is mentioned first, so that's the first number. So bluebirds are on top and sparrows are on the bottom. So we're told there's 48 bluebirds, so our bluebirds have to be on the top because, again, 8 represents the bluebirds. And we're going to write S for sparrows. So this is a proportion where, again, we don't have to cross multiply. All we have to do is multiply both sides of the fraction on the left by 6, because we know 8 times 6 is 48. So in these problems, we don't have to use a lot of sophisticated algorithms. Because the numerators are both 48, we know there are 42 sparrows. The denominators have to be the same. 42 sparrows. And make sure that you say sparrows or else you get a point taken off. Now if you use the method of equivalent ratios, then you would say 8 to 7, and we want this number, we want this number to be 48. So we have to multiply 8 by 6, so we have to multiply 7 by 6 to get 42, and then you'd write 42 sparrows. So that's the method of equivalent ratios. All right, try number 38, and when you come back, we'll do it together. All right, if the ratio of the number of cups of flour to the number of cups of oil in a recipe is 4 to 3, how many cups of oil will be necessary if there are 16 cups of flour? So let's try using the proportion method again. I'm going to use a thinner pen here so I can fit this stuff in. 4 over 3 is equal to, and we're looking for cups of oil, and we have cups of flour. So it says flour first. So that goes on the top. And we'll just put C for cups of oil. Multiply both sides of the left fraction by 4, and you get 16 over 12 equals 16 over C. So therefore, C must be 12. 12 cups flour. Wait, I'm sorry. That'd be 12 cups of oil. All right. So now if you do it with the other method, it'll be 4 to 3, and we want this number. We want this number to be. We know this number is 16. We're going to find this number. So obviously we'd multiply 4 by 4 to get 16. So we multiply 3 by 4, and we can see the answer is 12. Try number 39, and when you come back, we'll do it together. All right, we're back. I'm going to use the proportion method. 2 over 9 is equal to hats to jackets. So we'll put H for hats. All right, so we're going to multiply both sides of this fraction by 10, and you get 20 over 90 is equal to H over 90. So obviously H is equal to, I guess I can just write it down here, H is equal to 20 hats. So if you got 20 hats, good job. If you want to use the method of equivalent ratios, we do 2 to 9, and we're going to multiply. You just multiply. You can just go straight there, or you can do a bunch of intermediate steps, but we want this number to be 90. So obviously you just multiply 9 by 10 if you want to get there faster. So multiply 2 by 10, and you get 20, and you can see 20 is the answer. But again, you have to say 20 hats. You can't just write the number 20. All right, why don't you try number 40? When you come back, we'll do it together. All right, we're back. So I'll start with the proportion method. The ratio of bagels to donuts is 2 to 5, and there are 15 donuts. Put B for bagels. How many bagels are there? Again, multiply both numbers by 3, and you get 6 over 15, and we can see immediately that the number of bagels must be 6. B equals 6 bagels. Again, if there's 15 donuts, there must be 6 bagels if we maintain this ratio. These are all proportion problems. These problems might seem very similar to the problems we did in the last class, but they're slightly different because these problems require you to set up a proportion. Let's see here. Let's try it with the equivalent ratios method. So we have 2 to 5, and this is donuts and this is bagels. And by the way, I recommend that you put these letters on the top so you don't get confused. I should have been doing that myself. So bagels to donuts is 2 to 5, and we know we have 15 donuts, so we multiply 5 by 3 to get 15, so we have to multiply 2 by 3, and we see the answer is 6. So that's another way to do it. So now we're going to problems that require, or the problems that use ratios with 3 numbers. The ratio of Chevy trucks to Ford trucks to Dodge trucks is 3 to 8 to 2. If there are 32 Ford trucks, how many Chevy and Dodge trucks are there? So again, this is a ratio. But if we were going to use the method where we set up a proportion statement with an equation, then we'd have to actually set up 2 proportion statements. So that would take a while. So the best method is to use equivalent ratios. So we have 3 to 8 to 2, and I'm going to write letters above so I don't get confused myself. That's Chevy trucks, Ford trucks, and Dodge trucks. And I know it's that order because that's the order that was in the sentence. So we're told there are 32 Ford trucks. So we have to figure out what these numbers are. So as you can see, it's very easy. You just multiply 8 by 4 to get 32. So we have to multiply these other numbers by 4. So 2 times 4 is 8. 3 times 4 is 12. And these are our answers. So there are 12 Chevy trucks. I guess I'll just write this down here. And 8 Dodge trucks. Again, if you don't write the letters up here, it tends to get kind of confusing. So that helps quite a bit to organize this in your head. All right, so now if you're wondering how we would solve that with proportions, again, we have to write 2 equations. So I'm going to just show you how to do this with the other method. So we have the ratio of Chevy trucks to Ford trucks. So the ratio of Chevy trucks to Ford trucks is 3 over 8. And we know that we have 32 Ford trucks. And we're looking for the number of Chevy trucks. So you'd have to set up that proportion and solve that proportion. And you would also have to set up another proportion. So the ratio of, so that was the ratio of Chevy to Ford, but you'd have to set up the ratio of Ford to Dodge in the next one. So 8 over 2, Ford to Dodge. And there are 32 Fords. And again, multiply both sides of this fraction by 4, and then you get 32 in the numerator and 8 in the denominator, so Dodge trucks is 8. So that's why we didn't use this method, because we'd have to set up 2 equations. It'd be a lot faster if we use this method. So why don't you try number 42, and when you come back, we'll do it together. You can use either method. All right, we're back. I'm going to use the faster method. So we have 2 to 1 to 5, and quarters represents the last number. Whoops. So we want to find what these numbers are. So we had to multiply 5 by 4, so that means we have to multiply all the other numbers by 4. 1 times 4 is 4, 2 times 4 is 8. And there you go. Done. So the final answer is there are 8 dimes and 4 nickels. So if you got 8 dimes and 4 nickels, good job. Why don't you try number 43, and when you come back, we'll do it together. All right, we're back. So 8 to 7 to 2 is the ratios, and that's pens to erasers to pens, or pencils. Pencils to erasers to pens. And those P's are the same. There's not much we can do about that. And it says pencils 24. We have 24 pencils. So we're looking for the underline number, the underline spaces there. So you have to multiply 8 by 3 to get 24. So multiply 7 by 3 and we get 21. 2 by 3 to get 6. And it says how many erasers and pens are there? So there are 21 erasers. And there are 6 pens. So if you got 21 erasers and 6 pens, good job. Why don't you try number 44, and when you come back, we'll do it together. All right, we're back. Our ratio is 2 to 2 to 3. And that's almonds to cashews to walnuts. And it says there are 10 cashews. So if there are 10 cashews, what are the other numbers? Well, we have to multiply 2 by 5 to get 10, so we multiply all the other numbers by 5. And we see we have 10 almonds and 15 walnuts. So if you got 10 almonds and 15 walnuts, good job. So again, those were word problems that required you to use proportions. And you can use an equation, or you can use the method of equivalent ratios to solve the proportion, but they're all proportion problems. So now we're going to go to some challenge problems. We have 1, 2, 3, 4, 5, 6, 7 more problems to do here, and then we'll be done for the day. I'll be done. You'll have to do the homework, unfortunately. I know that's depressing, but you got to do it. If the ratio of the number of paper clips to the total number of paper clips and staples is 4 to 11, and there are 35 staples, how many paper clips are there? So these are challenge problems. They're not really that difficult, but they're more complicated than the problems we did previously. So let's read that again. If the ratio of the number of paper clips to the total number of paper clips and staples is 4 to 11, and there are 35 staples, how many paper clips are there? So let's write this down. 4 to 11 is the ratio. And it says it's the ratio of the number of paper clips to the total number of paper clips and staples. So this number represents paper clips, and this number represents the total number of paper clips and staples. So if you add the number of paper clips and you add and the number of staples, you get 11. And it says if there are 35 staples, how many paper clips are there? So the problem is we need the ratio of paper clips to staples in order to solve this problem. we don't have the ratio of paper clips to staples. We have the ratio of paper clips to the total number of paper clips and staples. So what we have to do is we have to figure out this ratio. But if 11 is the total, all you do is just take 11 and subtract 4, because first of all, we already have this number. We're just looking for this number. So you just take 11, which is the total, and subtract 4, and that gives you 7. So there you go. Now we have the ratio of paper clips to staples. I know that seems difficult, but it's really pretty simple. And now it just becomes the same type of problem we solved before. So we know that the ratio is 4 to 7 for paper clips to staples, and they tell us we have 35 staples. So what would this number be? Well, we multiplied 7 by 5 to get 35, so we have to multiply 4 by 5 also, and that gives us our answer. There are 20 paper clips. So this problem isn't really that difficult, it's just more complicated than the problems we did before. Let's do another one of those together. The ratio of the number of hamsters to the difference between the number of rats and hamsters is 9 to 2. How many rats are there if the number of hamsters is 81? So let's write this ratio. We get 9 to 2, and that's the number of hamsters. That's the number of hamsters to the difference between the number of rats and hamsters. So that's R minus H. And the reason I know it's R minus H and not H minus R is because it said rats first, then hamsters, when it said the difference. So rats comes first. Rats minus hamsters. So again, this is a problem where they don't give us the right ratio. We need the ratio of hamsters to rats in order to solve this problem. We know the number of hamsters, or the number for the relation is 9 for hamsters, but we need the number of rats. So in this case, it's the difference between the number of rats and hamsters equals 2. So that means the number of rats minus the number of hamsters equals 2. But we already know the number of hamsters is 9, or at least the number we're using for the relation is 9. And so R minus 9 is 2. So what is R? Well, R has to be 11. So now we know the ratio of the number of hamsters to the number of rats is 9 to 11. So now we can solve the problem. We know that the number of hamsters is 81. So we have to figure out this number. In order to get 81, we had to multiply 9 by 9. So we have to multiply 11 by 9 also, and we get 99 rats. 99 rats. All right, now on to 47. So these problems all have different variations here. So every one of these challenge problems is slightly different. So you're going to have to try one of these eventually on your own. So this problem is not going to be exactly the same as the previous problems, but you can still figure it out. If you get stuck, we can do it together. And if you don't get stuck, we'll do it together anyway. So try number 47, and when you come back, we'll do it together. All right, we're back. If the ratio of the number of bags to the number of cups is 6 to 7, and there are 60 bags, what is the sum of the number of cups and the number of bags? So we have to add the number of cups and the number of bags, but the problem is we don't have the number of bags. But we know that if the ratio is 6 to 7, and there are 60 bags, we just multiply 6 by 10 to get 60, which means we have to multiply 7 by 10 also. Again, we multiplied 6 by 10. We have to multiply 7 by 10 to maintain that ratio. So we get 70 cups. So the reason that we did that is it's asking what is the sum of the number of cups and the number of bags. We couldn't figure out the sum unless we had the two numbers. We didn't have the two numbers. We only had one number, but we used this ratio to give us the other numbers. So now we just add 60 plus 70, equals 130. And if you're not comfortable doing that in your head, you can just set it up vertically like we learned in one of the previous classes. And there you go, 130. So 130 bags and cups. So if you got the right answer, good job. If you didn't, that's okay. Word problems take a long time to get used to, so don't be alarmed if you're having trouble with these. Every student has trouble with word problems, without exception. All right, number 48. Even the students that don't have problems with word problems, they did in the past. They just figured out how to solve them, and now they know them. Now they're used to them. So everybody has to get used to these. So try number 48, and when you come back, we'll do it together. If the ratio of the difference between the number of red balloons and the number of green balloons to the number of green balloons is 5 to 8, and there are 24 green balloons, how many red balloons are there? So let's write this ratio, and that's the ratio of the difference between the number of red balloons and the number of green balloons to the number of green balloons. Let me move this over, put that question mark up there. So that's the ratio that they gave us. And they want to know if there are 24 green balloons, how many red balloons are there? So if there are 24 green balloons, how many red balloons are there? Problem is we don't have the ratio of red balloons to green balloons. We have the difference of the ratio, or we have the difference of the number of red balloons to green balloons, or the difference between the number of red balloons and green balloons to the number of green balloons. So number of red balloons minus number of green balloons equals 5, and we know the number of green balloons is 8. So we can just erase that and write 8. So what number minus 8 equals 5? Well, obviously you just add 8 and 5 and you get 13. So the number of red balloons is 13. So let's change this to the lowest terms, numbers in the lowest terms. We get 8 there and 13 there. So the ratio of number of red balloons to number of green balloons is 13 to 8. All right, so now they want to know if there are 24 green balloons, how many red balloons are there? Well, you just multiply 8 by 3. So 3 times 13 is 39, so there are 39 red balloons. Again, if you're having trouble with these word problems, that's okay. Every student has trouble with word problems. The only way to get better at these problems is to do more and more practice problems. So that's what the homework is for. All right, 49. The ratio of the perimeter of a fence and the sum of the perimeters of the same fence and a wall is 5 to 12. So we have the perimeter of the fence and the sum of the perimeters of the fence and the wall. That's the ratio they gave us. And it wants to know, it says the perimeter of the fence is 10 feet. What is the perimeter of the wall? So if you have a ratio of the fence perimeter to the wall perimeter, and we know the fence number for the ratio is 5, we don't have the number for the ratio for the perimeter of the wall. And we're told the perimeter of the fence is 10 feet. So what is the perimeter of the wall? So first we have to find this number, then we can find this number. Again, these are challenge problems. So the total perimeter of the fence and the wall is 12, and we can consider the perimeter of the fence to be 5 for now. So we just subtract. 12 minus 5 is 7. So that's what W equals. So W we know is now 7. So the ratio of the perimeter of the fence and the wall is 5 to 7, and they tell us the actual perimeter of the fence is 10. So we have to multiply 5 by 2 to get 10. So multiply 7 by 2 and we get 14. So the perimeter of the wall is 14 14 feet. All right. Why don't you try number 50? Let's read it together before we do it. If the ratio of Donnie's cash to the sum of Donnie and Melissa's cash is 4 to 11, and the sum of their money is $33, how much cash does Melissa have? So why don't you attempt that problem, and when you come back, we'll do it together. Keep in mind, these are challenge problems. All right, we're back. So the ratio is 4 to 11. So that's the ratio of Donnie's cash and sum of Donnie and Melissa. And we're told that the sum of their money is $33. So this is actually going to be really easy, because we're told that this number is 33. And it says, how much cash does Melissa have? If we know that the sum is 33, and we have the ratio of Donnie's cash to Melissa's cash, which is 4 to 11, then we could just make this number 33, which means that you have to multiply 11 by 3 to get 33, so you have to multiply 4 by 3, and that tells us the amount that Donnie has, Donnie's cash. Now that doesn't give us the answer. That just tells us how much cash Donnie has, but we know that the total cash of both people is $33. So Melissa's cash is just $33 the total minus the amount of money that Donnie has, and that'll give us the amount of money that Melissa has. So it's 33 minus 12, and that would just be 21. $21. So Melissa has $21. So we got that one right. Good job. If you didn't, don't be alarmed. These are challenge problems, so it's very common to make mistakes on these. So I think this is the last problem for the day, or for this class. It's not the last problem for the day, because if you do your homework right after this class, and you'll get it done quickly. That's the best way to organize your time. But the last problem of this class, if the ratio of the number of bubblegum sticks to the difference between the number of bubblegum sticks and jelly beans is 9 to 1, what is the total number of bubblegum sticks and jelly beans if there are 40 jelly beans? So why don't you try this problem, and when you come back, we'll do it together. All right, so our ratio that they give us is 9 to 1. And that's the ratio of number of bubblegum sticks to the difference between the number of bubblegum sticks and jelly beans. What is the total number of bubblegum sticks and jelly beans if there are 40 jelly beans? What is the total number of bubblegum sticks and jelly beans if there are 40 jelly beans? So first I'm going to find the ratio of bubblegum sticks to jelly beans. We don't have that. We know that bubblegum sticks minus jelly beans is 1. That's this information. And we know that the bubblegum sticks, we can use that number for the ratio. So 9 minus j, 9 minus what number is equal to 1? Well, obviously j would just be 8. So now we have bubblegum sticks is 9 and jelly beans is 8, so that gives us the ratio in lowest terms. But that's only the ratio in lowest terms. We're told that there are 40 jelly beans. So if there are 40 jelly beans and this ratio is maintained, how many bubblegum sticks are there? Well, you just multiply 8 times 5 to get 40. So multiply 9 by 5 and you get 45. Now we have the actual number of bubblegum sticks and the actual number of jelly beans. We add those two up because it says it wants the total number of bubblegum sticks and jelly beans. So we add those two up and we get 45 plus 40. You can do it vertically if you want, or you can just do it in your head. And we get 85 bubblegum sticks and jelly beans. So if you got 85, good job. If you didn't, that's okay. Again, if you're having trouble with these word problems, that's perfectly normal because these are challenge problems. You'll have more practice to do in the homework. So that's the last problem for this class. Let's go to the homework. You can take a screenshot of that, or you can take a screenshot of the first 2 pages and a screenshot of the second 2 pages. So that's class 26, and be sure to do the homework completely and correctly and check all your answers. If you get the wrong answer, that means you have to go back and fix the problem and do it correctly. If you get a wrong answer, you don't just go on to the next one and forget that you got the wrong answer, or else you're not going to learn anything. So make sure that you do the homework completely and correctly and show all your work. And I'll look forward to seeing you in class 27.